We have an equation involving rational expressions, and we do not have the special case because we do not just have two equal fractions. We have this 3b here in the beginning. So we need to find our LCD. None of the denominators are factorable. Now the denominator of this first expression is really 1, so we don't even have to consider that. In this second expression, the denominator is 2, so that has to be a factor. And in this last expression, the denominator is 2b. So we need a factor of 2, which we have. We also need a factor of b. That's our LCD. And now we're going to multiply every term by our LCD. So I multiplied it by 3b. I'm going to multiply it by 1/2. And now I'm going to put it over 1. Here I didn't because I wasn't multiplying by a fraction. But here I am. I'm multiplying by 1/2. And in this last expression, I'm going to put it over 1 because I'm multiplying by a fraction. 2b times 3b. Make sure you multiply your b's correctly. 2 times 3 is 6. b times b is b squared. I wasn't concerned about the minus here because we only have one term in both numerators, so it's not going to be an issue. It's an issue when you have addition and subtraction going on. You have to make sure to distribute. So we're going to cancel the 2 in this numerator with the 2 in that denominator, and that leaves us with minus b. And in this last expression, we can cancel the 2's. We can cancel the b's. And we're left with 5 over 1, which is just 5. So now we're left with just an equation, and we have to determine what type of equation it is. Well, I see b squared here, so right away I'm thinking I need 0 on one side so I can try to factor to solve. So we have 6b squared minus b minus 5. These are not like terms, we can't combine them. And that equals 0. Now we're ready to factor. Set up our double parentheses. It's a trinomial. Could be 6 and 1, could be 2 and 3. I have no idea. Let's try 2 and 3. 2b and 3b. Opposite signs, because the last term is negative. Well, the only possibilities are 5 and 1 or 1 and 5. Well, let's try 5 here and 1 here. We get 15b minus 2b, and that's 13b. That's not what we wanted. So that didn't work. Let me go over here now. I'm going to keep the 2b, and I'm going to keep the 3b, but I'm going to switch the 5 and the 1. Now the inners give us 3b. The outers give us negative 10b. And of course that adds up to negative 7b. So that didn't work either. So now I need to try again. Let's see if I can get rid of this. We've used up all the possibilities with 2b and 3b. So that part is not correct. So let's go back and set up our parentheses. And of course, the other way to get 6 is 6b times 1b. And now let's plug in our signs, which are still opposite signs. And the possibilities again are 5 and 1 or 1 and 5. The inners multiply to be 5b. The outers multiply to be negative 6b. Add them up and we get negative 1b, which is just negative b. Is that what we wanted? Yes, it is. So this is factored correctly. Now we're ready to set each factor equal to 0 and solve. So 6b plus 5 equals 0, and b minus 1 equals 0. Well, the second one's easier. We just add 1 to both sides, and we're left with b equals 1. First one, we subtract 5 from both sides. We get 6b equals negative 5, and now we divide both sides by 6, and we get b equals negative 5, 6. All right. If I put negative 5, 6 in for b in this denominator, will I get 0? No. So that's fine. If I put b equals 1 in this denominator, would I get 0? No, I'd get 2. So I do get two solutions, negative 5, 6, and 1. Notice I did not have to plug them into the equation to make certain the equation worked. I just had to make certain that neither one made any denominator equal to 0.